Good afternoon, ladies and gentlemen. Today we are going to explain the topic of framework for information and help desk systems based on blockchain technologies. My name is Renzo Diaz. I'm a Bachelor of Science in System Engineering, and with the help of Andres Mares, also a Bachelor of Science in System Engineering, and the guidance of Lenny Wang, a PhD in System Engineering, we have developed this framework in order to help to incorporate blockchain technologies into some kind of systems. Okay, so let's start with the motivation. A study published by Deb Myers stated that in many institutions, it has been detected that up to 75% of help desk resources are interested in training staff. So information is being treated by non-prepared staff. Also, the website helpdesk.com noted that in most information security policies are aimed at privacy and availability of data sent, and leave aside the integrity of information guarded by the systems. From these two statistics, we have extrapolated some internal and external threats. In the external threats, we have vulnerabilities on traditional help desk systems that allow the alteration of data without the manager of the knowledge. Also, from the internal threats, we have enough skills to handle data of the help desk system among the staff. Now, the purpose of this study is that, multiple studies present solutions by using technologies like artificial intelligence and machine learning. And there are no approach that include the usage of blockchain or IPFS technologies. For this reason, a framework is proposed for the implementation of blockchain and IPFS technologies in help desk systems to the purpose to be able to guarantee the three fundamental pillars of computing: immutability of the information, confidentiality of data, and availability of the system. Now, let's look on the related work. For this investigation, we used quartile 1 and 2 papers dated from 2019 to 2022. We divided these papers into 3 topics: artificial intelligence, that were usually aimed at minimizing the response time for ticket handling. By doing this, trying to minimize the window breach of which the data is exposed to threats. Also, machine learning that optimizing text analysis algorithms for ticket classification. By doing so, you can deliver the correct ticket to the correct and properly trained staff. And some papers about traditional help desk systems that were focused on applying improvements to already existing systems. Okay, so now let's talk about some key terms that we're going to use in this presentation. First of all, a blockchain network is a distributed and centralized digital ledger that records transactions across the network of computers, providing transparency, security, and immutability. Then, IPFS network. IPFS is a peer-to-peer database created to have a resilient way of store and share data. And something important to know about this system is that it uses hashing addressing and cryptographic hashing to data retrieval. So if you have a hash of a file, you can retrieve the file from that network. And finally, a hash algorithm is basically a function that takes any arbitrary amount of data and sums it up in a digital fingerprint of a fixed length. Now, the proposed framework consists of using a first-generation blockchain such as Bitcoin, Digibyte, Litecoin, Dogecoin to store the hash of collected information by the system, and use IPFS to store the backup of the information in decentralized nodes. We're going to look into these 3 phases in the next slides. So the first one is data abstraction. Once you have your system already planned, already built, and you have, for example, the ER diagram, the entity relationship diagram, what you're going to do is to select the most important entities of this diagram or of the system, and the ones that needs to be secure, and identify which attributes needs to be secure and can't be mutated through time. In this case, we choose tickets and messages that are the most important ones in the system. There's one that holds the whole information, like messages that are being sent through users, and some of the attributes that were selected, such as the subject, the ticket ID, or the message and the text that the user writes. Then once we completed the first phase, we go to the phase number 2, which is the deployment of the centralized technologies. In this case, we first of all we need to make a benchmark among among the different blockchains to know which one to use. In this case, we just picked one of the most famous ones, like Bitcoin, Litecoin, and Digibit, and we made a benchmark based on the necessities of the system. If your system is aimed at to saving as much as data as possible, you may want to use the fastest blockchain. In this case, we select Digibit for that exact same reason. Then the next step is to have a blockchain endpoint deployed, so a way to communicate with this blockchain. In this case, we use a public node that is available in the Digit Explorer endpoint. This is run by the Digibit Foundation, so it's enough for the purpose of test the case of study. Then to deploy the endpoint for IPFS to be able to connect to an IPFS network, we use the Infura API. This allows us to connect to this network. It's a public deployment, so it allows us to test this case of study, but probably in a more professional approach, we may want to have a private network just for security reasons. And then, in the phase 3, we have the implementation of the centralized technologies. In this case, we're going to take all the tools that we already have deployed and built and integrate them into our system. In this case, we have the physical architecture and the logical architecture. And we append next to the both architectures our blockchain models. So we have in this case, for example, in the downside of the physical architecture, the Digibit and the IPFS network models. So these just were appended to the diagrams. So it can be included into already existent helpdesk systems. The same case in the logical architecture. In this case, we have a modular architecture based on a Node.js types of style of development. And if you see on the right side of the diagram, we have appended the blockchain API and the IPFS API next to some code. But if we remove those, the system is still a functional helpdesk system. So it's just a matter of migrate the security layers to a global blockchain. Then, when we implemented some processes, we have processes to storing the data in the blockchain and in IPFS. In this case, in the blockchain, we only store the hash. So we retrieve the data from the database, we hash it out, put the hash in the blockchain and the information in IPFS. The verifying process that is retrieving the same data from from the database, hashing it out again, and contrast its hash with the blockchain and check if they match. If they don't match, you go to the recovery process, which is just claiming the same information with the hash that you just got from the blockchain, from IPFS, and that way you have a reliable way to get that information back because it has the same hash, so you know that it's not being altered. Now, to test this case of study, we have developed an application. In this case, it's just a basic helpdesk system that incorporates or that implements the basic flow of ticket answering. In this case, we have ticket that's been answered. Then we have some errors here. You see that the data of the system has been deleted. And with the correct management of the system, it's successfully recovered. Now, for the validation, we test this application against 2 experiments. The experiment 1, that is about user interaction, is oriented at testing information assurance mechanisms. So it's about taking the information that the system got from the testing and actually put that in the blockchain and into IPFS and just test it out the first 2 mechanisms. Now, experiment 2, it's about attack recovery. We simulated attacks on these systems and we try to force the system to make a fault and to be able to recover that information from IPFS. For the experiment 1, the user interaction, a group of 6 participants with previous experience using helpdesk system were assigned a role, user support and administration, and assigned some tasks. These tests were just aimed to test the system and to make traffic, to generate tickets, generate answers, but not to stress out the system. So we don't generate a massive volume of data, just enough to have this function tested out. With this information, we proceed with experiment 2, the attack recovery, where we simulated an SQL injection of these into the system By running out some attacks, for example, in the table tickets, we changes, for example, all the subjects to you've been attacked. So we changed the information inside the system through a vulnerability that was intentionally located into the code, and allowing this, or by doing so, we then left, or well, we then leave the system to just check its data by its own and to try for it to detect if something changed. And well, right, it works. The result of the experiment 1, for example, in the first variable, we confirmed that the average time that the system was able to secure information was around 15 seconds. So in a 15 seconds time span, the system was able to get an information secured by the blockchain or send it out to the blockchain, and this time correlates with the time that the blockchain that we use takes to produce a block. In this case, the number of transactions were 38, so we tried 38 times really fast to use the system, and then we measure how many times each of the functions were called. In this case, as we're testing the information assurance part, the only possible result that was able to validate this proposal was 100%, because that's actually what we are looking at. Then in experiment 2, we have the inconsistency detection time that is around 10 to 11 minutes. This is because it takes around 40 blocks, so 10 to 11 minutes, to successfully validate a transaction by the blockchain and to be sure that it's not going to be changed by some external attacks to the network. So now we worry about the attacks to the network, not to the system. So the security layer of the system has been moved out to the blockchain. Once again, the percentage or the indicators in these experiments are aimed to test the efficiency of the proposal. So the only valid result was 100%. Now, in conclusion, we have that the usage of decentralized technologies allows the algorithm through which the system secures the data to be virtually unbreakable. And I'm going to put a lot of emphasis in virtually, because the usage of decentralized technologies migrates the security layer to the system, to a blockchain. So now you have a full community working out to secure this technology, and it can be updated through time. One of the capabilities of a blockchain system is that it can be updated or migrated to support new kinds of attacks, new kinds of technologies, and be stronger through time. Then the time which the system secure the data depends directly of the block time of the blockchain use. This means that you need to be very picky when you choose a blockchain to begin with, because this framework technically works with any first generation blockchain, but you need to be, or the team implementing this needs to be aware of the kind of blockchain that they're going to use in order to provide the best result for their interests. Well, that's basically all the conclusions. The discussions were I tried to merge it with the conclusions, but one thing that I would like to add here is that there's so much space for the research community to grow up from this idea, because these kind of frameworks can be scaled through time, and new mechanisms to secure the data in fewer transactions can be made, and those are things that might be worth of study in the future.